To work a problem that is a limit involving a square root, what we're going to take advantage of is the difference of squares formula. To remind you what that is, the difference of squares looks like a squared minus b squared factors as a plus b times a minus b. What's important is both terms on the left-hand side are perfect squares. So if a or b happen to be square roots, when you square those values, they become whole numbers. That's what we're going to take advantage of. So in this case, we're going to say the value a is the square root of 6x plus 9, and the value b is 3. So in order to set up the difference of squares, I have to set up a plus b times a minus b, which is why we always set up these problems using conjugate pairs. So if I multiply top and bottom by the conjugate, I am purposefully setting up the difference of squares. And that's going to enable me to get rid of that square root that's in the numerator. And that square root is ultimately what's giving us the division by 0. So for instance, if I plug in x equals 0, 6 times 0 is 0, plus 9. When I take the square root of that, that's 3. So 3 minus 3 in the numerator is 0, divided by 0, we get this 0 over 0 form. So I'm trying to manipulate this problem algebraically so that it becomes something that I can evaluate analytically in the end. And the difference of squares is going to do that for us. So I now have effectively set up a minus b times a plus b, which, according to the difference of squares formula, becomes a squared minus b squared. The denominator does get that square root, and it's not going to disappear altogether. But what's going to happen is this is going to change into a form that we can make this so that we don't get 0 over 0. All right, the next step in the process, when I square a square root, that square root just disappears. These are inverse operations. 3 squared is 9, and denominator stays the same. But this positive 9 and negative 9 cancel out, and then I just have 6x in the numerator. 6x and the x factor in the denominator will cancel, which leaves me with the limit as x goes to 0 of 6 over the square root of 6x plus 9 plus 3. So a much different form than what I had originally. Now, if I let x go to 0, so I'm now evaluating this limit by letting x go to 0, it would be 6 over the square root of 6 times 0 plus 9, which would just be 9, plus 3. So 6 over the square root of 9 is 3, plus 3, so 6 over 6, which is 1. And since that's a real number, that's the value of my limit.